Okay, let us discuss this program. So this is a basically easy program, rotation about fixed axis. So this program has something to do with rotation, and this is a pure rotation about fixed axis. So let us copy this one, rotation about fixed axis. So we'll discuss 2-3 problems corresponding to rotation about fixed axis. So what this problem says, so let me first make a diagram. So I have a disk or ring. This is a disk. So let me make the disk first, and then we'll discuss what the problem says. So there is a disk, circular disk. Question says a uniform circular disk of mass m and radius r. So this means mass of the disk is given to you and radius is also given to you, and center is free to turn in odd plane, and this is the center O. It's free to turn in one plane about a smooth horizontal axis passing through A. So there is a point A, and this is basically axis. So point A is acting as an axis, so there is something fixed. So this disk can rotate about this axis. So let us say there is an axis that passes through this point. Are you getting? So there is an axis, and this axis passes through this point. So this is the axis. Are you getting? So this object can rotate about this axis freely. Initially the AO is horizontal. So initially this is given, AO is horizontal. Now it says A is on the point A is on the rim of the disk. Of course this is on the rim of the disk. The disk is released from rest in position in which OA is horizontal. Initially OA is horizontal, and then disk has been released. And finally disk becomes vertical. So after some time what happens, your disk becomes vertical. So this point is A. So now it has rotated and it will become something like this. So this is point A. Are you getting or not? So if you rotate this one, it is rotating. Now this point will come here. So this is O is center here. Are you getting or not? Now the questions ask, find the angular velocity of the disk when OA is first become vertical. So angular velocity of disk, I have to find what is the omega. So what is the angular velocity of disk? Are you getting? So how will you proceed? This is an easy problem, fairly easy problem. You see what is happening, there is a loss in potential energy. You have initially the potential energy is here. Now mgr, that has the potential energy loss, and you see the potential energy lost has gone into the kinetic energy of disk. So you can write energy conservation equation, you will get the final answer. Let me wait for 1 minute. This disk is basically rotating about this axis, so let us say omega is about this axis. Okay, so how many of you have done? So let us see first. So what is the loss in potential energy? So first let us see loss in potential energy. Initially the potential energy is here. Now this has come to r distance lower, so center of mass has lowered by distance r. So loss in potential energy is nothing but mgr. Are you getting? Now let us say what is the gain in kinetic energy. So gain in kinetic energy I can write. If you see about this axis, so this is a pure rotation. So about this axis, this is a case of pure rotation. So gain in kinetic energy is half I omega square. But now I should be about this axis, because about this axis there is a pure rotation. So I have to find I. So what will be the I? About center of mass I know for disk, mr square by 2 is the moment of inertia, and this distance is mr square if I use the parallel axis theorem. So mr square I have to add more ICM, so I am applying ICM plus md square formula. You getting, using the parallel axis theorem. So this becomes, so 3 by 2 mr square. Are you getting or not? And now the loss in potential energy should be equal to gain in kinetic energy. If I apply this, mgr, that is the loss in potential energy, is equals to gain in kinetic energy half I and then omega square. Are you getting or not? If you solve from here, so r cancels out, so you will have 4 by 3 gr, so 4 by 3 zr. You getting 4 by 3 gr by r square, that is the omega square. So 4 by 3 gr by r square, so we can also write omega square is equals to 4 by 3 g by r. Are you getting or not? So omega is nothing but under root and 2, let us go outside, so g by 3r. So you will get this omega. Are you getting or not? This is so simple. You just copy this one. If you have not copied, there is no point of copying. This is so simple problems. Even it can be asked in objective kind of question. So you see, this question we said there is a rotation about this axis, that the axis passing through A, there is a case of pure rotation. So only about axis A there is a case of pure rotation, and that's why I have to take moment of inertia about that axis. I cannot take moment of inertia about the center of mass. It's not in pure rotation about the center of mass. It is only in pure rotation about the axis passing through A, and that's why I have taken omega through axis, that axis, and I have to take I, that is about that axis. Are you getting on? That's why I have to translate the moment of inertia from center of mass to the axis passing through A, that is mr square by 2 plus mr square. I think all of you have copied this one. So let us go for the next problem.